handful of employees. And I think from according to the business review, I think at the time it was written, it accounted for about 60% of the company's ad revenue. So just to give you an idea, being able to take a handful of employees and build out a multi-billion-dollar application, how does that kind of get done? And a lot of this is through organizational enablers. One of the kind of methodologies that we use is this idea of a shared services platform. And SSP is really highly specialized, highly functional engineering teams that help pull problems away from the business and provide them with off-the-shelf best practice solutions that are available. Tightly integrated, set up so that engineering is never the bottleneck on the business's momentum. So this was probably the most powerful quote that I kind of saw. It really does sum up what we're trying to do and how the mindset of software is built, and trying to bring this into open source tools and infrastructure tools that are not necessarily oriented for developers, but more for producing business value, with the side effect of making sure that it's a good experience for developers. Really what it comes down to is a lot of businesses do not put the organizational enablement in place to overcome these fiefdoms mindsets that start to show up inside the business. So, getting into it, a bit of more background. ByteDance is Federation's largest user. Our kind of scale that we operate at, last time I checked, was 15,000 front ends. We've got about 10,000 front end engineers. There's a minimum of 10,000 weekly deployments across over 1,000 business products that we own. If you know Federation a little bit, the terminology we have is kind of hosts or remotes, things that consume modules and share them. And in our stack, we have thousands of all of them. Some applications can be composed by hundreds, deployed to maybe 50 regions in the world, and it all has to be controlled very well. And Federation wasn't really built for that scale, at least not in my design. I thought maybe, hey, 20 remotes would be great. So never thought of 100, 1,000 to manage something. So back to the drawing board we went, and we kind of came up with the V2 design. So some of the major things we wanted to look into here is addressing a lot of user concerns, addressing a lot of scaling issues that kind of came with the initial design, making sure that it's bundler agnostic and decoupled from Webpack, and really to start working toward engineering throughput, deterministic stability, flexibility, and really to try and tighten up that user experience to make sure that it is on par with something that was not a distributed front end or micro front end type architecture. So to give you an idea of some of the new things that have come out in V2, the biggest one that I'm a huge fan of is the runtime API. So I don't have a code snippet of a new API I added, but if any of you saw a talk from Manfred from the Angular side of things, he uses a native federation. You might have heard of that as well. So we've kind of been trying to collaborate here to figure out how do we bring this runtime outside of one, Webpack, and two, how can we bring it to different kind of web technologies, something like import maps. So one of the APIs that I ended up adding to the runtime was this concept of create container. So the biggest challenge I've run into, what coupled Federation so tightly to a bundler, is there's many ways that you could consume the code, but you couldn't necessarily create the interfaces to be consumed by others without a compiler behind the scenes to put the main interface together for you. So we ended up creating create container, and that's what ESBuild uses. You can just go export default create container and drop in basically the same configuration you would put on the compiler plugin that you saw in the beginning or any of these options. The only real difference in create container is there's an exposes value, so you can actually expose or export your modules out for anyone else to use. And in theory, the idea is you could use this with Vite, you could use this with ESBuild, you could use this with Rollup, you could use this with anything that could execute JavaScript. So in our runtime API, you can see some of the ones that I do have a screenshot of. But essentially here, if we wanted to initialize and consume various parts, that's kind of what initialization would look like. If you wanted to share something, this is how you could share your modules. In this example, I just import React at the top. This could be useful if you use UMDs or other kind of external loading systems that don't necessarily fit into the original design. But you can also just use a dynamic import there. You could say, hey, if I want this version of React 17, I can load it only when needed and still keep recycling that dependency set. We've also introduced this concept of runtime plugins. Now, runtime plugins, what's a good word for it? I really enjoy taking something and doing everything you shouldn't do with it. So when you say, oh yeah, we can do that, but should you? I'm always saying, well, how far could I just kind of push things? And this has been a great way to come up with some very interesting ideas easily. But the nice thing as well is it also exposes the core of Federation to you without actually having to really learn a ton about how it operates, think about workarounds, or if you run into problems that maybe I didn't think of, you don't have to file Git issues necessarily and wait for the maintaining team to pick it up. You can extend it heavily. So what the runtime plugin concept is obviously it's at runtime, not compile time. So you could register these things just loosely in your code anywhere as you want. You can also just require resolve the file in an option on the bundler plugin. But the general idea here is that you have something similar to like a request response lifecycle. But this request response lifecycle is for the dependency loading system for code. So when you go to import something, before you initialize the containers, you can change the options. You can say before an import begins to make its way out of the runtime, you can catch it, see what's about to be requested. You could check authentication. You could, instantiate something based on personalization, anything that you wanted. And you've got various other ones. Offload hook, loading share. You can intercept all of these and basically give you the full lifecycle control on what you want to do. I kind of just refer to the pattern as a full-way handshake. Got the idea from when you do a Wi-Fi authentication. The big challenge I found with the previous design is if you wanted to do stuff like this, you could kind of hack it, but you could only hack it on the consumer. So it wasn't something where you could actually write runtime plugins as a team who provides code to other applications. And if, say, you don't want your code to be consumed by that, maybe there's off, maybe there's compatibility issues, compliance, the providing team didn't really have any power to reject consumption. But with the four-way handshake, both of them can choose if they want to establish a connection to each other or not. And you can always bail out of them and reroute your dependencies to, say, somewhere else. So I guess one other last thing I want to say is when I kind of call this thing import middleware, what you end up seeing in your code base when you've got an import from or dynamic import or require, if they are federated ones, all that means in your code base is this is a slot where the export can be anything that I want, and I can decide it at runtime as the import begins to be made out. So it gives you a ton of flexibility in the code base, but your engineers generally don't really need to learn anything new. If you know how to require code, boom, you're good. Nobody needs to learn any new things, custom APIs. It's just normal import for most cases. So to give you an example here, let's rewire an application and make it use different versions of various dependencies. The host is now using Lodash, a different version. What if we did something dangerous here and switched it to use a different version of React DOM? And now it's using 17, but 16 is React DOM. And I'm not recompiling the application. This is just browser state, whatever's available in the browser, and the new APIs that we have available from Federation. We can hook into them, see what's going on, and again, I can just create a simple React component that's all in memory, and you're able to rewire every dependency inside of your application on the fly, however you see fit. So a big issue that had come up in the past is what happens when an offline remote occurs. Essentially, you can't reach your deployed target. Similar if an external isn't online. If you've ever used externals before, you know the big issue is one, central point of failure, and two, it's quite limited and usually like a render blocking problem. So Federation suffered from similar kind of issues around if the container isn't available, the application will crash. You could sometimes catch it if you were using dynamic imports, but there's many cases where you can't, like if you're using React hooks. That can't be in a promise anywhere. So some kind of way needed to be available to one, if something isn't available, isn't going to exist, don't crash the application and provide the user a way to recover from the problem without necessarily having to think about it line by line every time they're implemented. Whether that's using error boundaries or suspense or trying to build out some kind of fallback system. What if all of that could be removed into a runtime plugin, since we now can control what require means for these series of imports. Code's a little larger here, but wait, that's the wrong screenshot. Wow. Okay. Hopefully I'll find the right one. But essentially, if I do pop it up, I'll kind of recorrelate it. But what you end up getting is a runtime plugin here, and what the runtime plugin would do is all it would do is call that error load remote hook you saw before, and it's a pretty simple API. The whole idea is if error load remote is called, if you return a function, that's the module exports the consumer is going to be using. So if whatever's offline, you get the data of what's wrong, where it's wrong, and then you can turn around and say, okay, well, maybe dynamically import something off NPM, or here's a little piece of JSX that just says component unavailable. The application still keeps functioning, it still receives a React component, everything is still rendered correctly. So this is kind of an example of what it looks like. If you've got the offline remote, there is an app too, but it's never online. So all you see here is the first application coming in. My React component in the load remote hook was set to just take the error that I received from the runtime and print it as a React component. And so now I'm rendering a React component instead of rendering the second button, but the application is still staying online. We have other kind of cool examples of runtime plugins here, like if you wanted to control all of your remotes through an API, you wanted to rewire them based on various scenarios. You can see here simple green-blue, and I can kind of go in here on the init hook. I'm using local storage right now, but you could use whatever you wanted to detect the environment, to detect the deployment you want to use, and you can pretty much rewrite the relationships at each node in the graph. So if you've got a header, and header imports button, and button imports cart, each one can have their own plugin that applies to their context and understands the relationship of themselves to their parent, to the root parent of the application. And you can use all this information to determine what you want to do with the dependency relationships in this part of the graph. Examples here, if you have something kind of like an API control remote. What if I don't want to have to, if-else imports for everything, like your personalizing or A/B testing or anything else like that? So a really nice thing here is the only thing that this code base has is import app2 button. And using a runtime plugin, I can say, well, when there's some kind of feature flag or something like this set, that static import is simply rewired to a different container that could be called something completely different. But my consuming code, I don't change any imports. I don't have to import something else. The code never needs to be redeployed, but every time I click it, I'm switching between two different code bases on the spot using the same kind of import slot that was originally written in the code base. You can do other various things like dynamic mapping. It's kind of similar to API-driven remotes or something like that. I have some remotes here. Obviously, those URLs don't work. And then what I'm actually doing is in the runtime plugin, again, some kind of way where I can find my map, how I want to do it. Easiest way to do it is just to show it in the code here, but imagine this was a fetch request or something else. And I can go in here and I can say, okay, before the request is made, I'm going to look into the hash map and I'm going to find a different container to replace the current one that's available there. And then this is a little bit, you have the initialize hook where you can do the same thing. But what's kind of nice about this is your application can already be up and running, and right before it's going to execute the next component or the next part of the kind of application graph, you could then use current information in the application to inform about the follow-up imports that are going to come lower down your application